Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list published on March 5th, 2026, just 3 days ago. It introduces a unified evaluation paradigm that tests a model's ability to actively acquire information, revealing that standard static benchmarks can actually underestimate mathematical capabilities by 20 to 50%. The paper is titled Interactive Benchmarks. And as we will see in the experiments later, the models show some really striking strategic behaviors with significant implications for how we measure true artificial intelligence. And for those interested in the implementation, the authors have shared their code on GitHub. So, Figure 1 breaks down the proposed framework, which treats evaluation as a sequential decision process between an agent and its environment. The left panel illustrates interactive proofs, which focus on truth-seeking in logic and math. In this setup, the agent poses queries to a fully informed judge, aiming to minimize uncertainty and converge on an objective truth. Then, on the right, the diagram shifts to interactive games. These evaluate strategic reasoning in scenarios like poker or a trust game, where the agent interacts with unpredictable environments or other players to maximize its expected long-term reward. Alright, Table 1 drives home why this active inquiry is so crucial. It displays the baseline accuracy of several frontier models, including GPT-5 and Gemini, on logic puzzles when they must answer without asking any questions. In this scenario, every single model scores exactly 0%. This complete failure confirms that solving these tasks depends entirely on a model's ability to gather evidence, making it a rigorous test of active reasoning. So, while Table 1 just highlighted the total failure of these models without interaction, Figure 2 shows what happens when they can actively ask questions over a 20-turn budget. The left panel plots the interactive accuracy of each model. Gemini 3 Flash clearly leads, successfully solving 30% of the puzzles, with GPT-5 Mini trailing at 17%, while QN 3 Max struggles at just 4%. Then, the right panel measures interaction efficiency by tracking the average number of turns needed for those solved cases. Kimi K2 thinking proves the most efficient by requiring only about 12 turns, whereas DeepSeek Vive 3.2 takes 18 turns, meaning it needs significantly more back and forth to reach the right conclusion. Okay, moving from logic puzzles to mathematical reasoning, Figure 3 compares the interactive approach to a static pass at K baseline. Pass at K simply means giving the model multiple independent tries to generate a full answer and checking if any succeed. The left panel shows that this static method underestimates the model's true capabilities by 20 to 50%, with Grok 4.1 fast reaching 77% accuracy when allowed to interact. Over on the right panel, we track efficiency. Qwen 3 Max uses the fewest turns at just over 5, but its lower overall accuracy implies it only handles specific problem types well. Meanwhile, DeepSeek V 3.2 again requires the most back and forth, taking 12 rounds to converge. Well, Figure 4 shifts to interactive games, evaluating these models in a Texas Hold'em poker tournament. The top left chart shows Gemini 3 Flash is the most profitable and stable player, while Grok 4.1 Fast and GPT-5 Mini also profit but with higher variance. On the top right, the versus PIP rate measures how often a player voluntarily invests in the pot. GPT-5 Mini plays aggressively here, matching its low fold rate shown below. Finally, the bottom left chart reveals that Gemini executes decisions rapidly, whereas GPT-5 Mini is much slower. Alright, after evaluating poker, Figure 5 moves to a trust game tournament. The left chart compares the average payoff per round against simple baselines like tit for tat. Only QN 3 Max and GPT-5 Mini manage to outperform these basic rules, taking the top scores. The right chart explains why, by tracking cooperation and betrayal rates. Qwen 3 Max and GPT-5 Mini cooperate 97% of the time, while Gemini 3 Flash and DeepSeek V 3.2 betray much more frequently, a strategy that ultimately hurts their overall performance. So, wrapping up, 2 key takeaways stand out. First, interactive evaluation uncovers latent capabilities that static datasets completely miss. Second, even the most advanced large language models still have a long way to go in complex, multi-turn strategic reasoning. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.